Hi team, we are still working on naming improper fractions. Some of you are feeling really strong with this. That's great. Let's keep it up so you know exactly how to name improper fractions anytime you have a fraction that shows more than one whole. Remember, anytime we find a denominator of a fraction, no matter what, we count the parts in one whole. So if I'm looking at this top model, I see 3 wholes. This one isn't the whole thing because it's not shaded in, but I still see 1, 2, 3 whole circles. And to get my denominator for this shaded or unshaded fraction, I need to see how many parts are in one of the holes. So pick any hole and zoom in because they all have the same amount. I notice that each hole has 3 parts, so my denominator has to be 3 because every one of these little parts is 1/3. Every unit fraction on this model is 1/3 because each of those pieces is 1 out of 3 equal parts. Now I need to name my shaded fraction, which is talking about the numerator of shaded parts. I see 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3 are shaded. And for that unshaded numerator, I see 1/3, 2/3 are not shaded. 7/3 are shaded, but 2/3 are not. Next model. Remember, zoom into one hole to find your denominator. If I'm looking at this model, my denominator will remain the same. How many parts are in one hole? 2. So your denominator has to be 2. There are 2 parts in each hole, which makes this a half, that's 1/2, that's 1/2, and that's 1/2, because every little part is 1 out of 2 parts. If we're looking at the shaded parts, we need to count those. That's 1/2, 2/2, 3 halves are shaded. If we're looking at unshaded, we see only 1 unshaded, which means that 1/2 is unshaded. 3 halves are shaded, 1/2 is not. Looking at the next model, oh, I see 4 holes. That doesn't matter. I need to find my denominator by looking at one hole and counting the parts in one hole. I see 6 parts in one hole. So I know my denominator is 6 because every little box on here is 1 out of 6. 1/6, 1/6, 1/6. Every fraction on here is 1/6. So if I need to count the shaded sixths, I see there are 1, 2, 3, 4, 5, 6. Plus another 6 will give me 12. You could keep counting. 7, 8, 9, 10, 11, 12. Plus another 6 give me 18, 12, 13, 14, 15, 16, 17, 18, 19 sixths, 20 sixths, 21 sixths are shaded. So how many are not? Well, 1/6, 2/6, 3/6 were not shaded. 21 of the sixths are shaded. 3 of the sixths are unshaded. All right, let's try 2 more. I see 3 holes, but how do I find my denominator? I hope you said count the parts in one of the holes. I see 4. These are fourths. Every little triangle here is 1/4, 1/4, 1/4. Every unit fraction on this model is going to be 1/4. So if I have to count my shaded parts, I see 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4. And don't forget, you could totally skip count those. Here's 4/4, makes 8/4, plus 1 more makes 9/4. There's your 9/4. How many are unshaded? 1/4, 2/4, 3/4. 9 of the fourths are shaded. 3 of the fourths are unshaded. All right, let's check out this last model. I see 2 holes, but how do I find my denominator? Count the parts in just one of the holes. I see 4 8 parts. So I know these are eighths. If I were to label each little triangle, they're all 1/8. 1/8. All my unit fractions are 1/8 because it's 1 part out of 8 total parts. Now to get the shaded fraction, we need to count the shaded parts. 1/8, 2/8, plus 8/8 gives me 10/8. 8, 9, 10/8. How many eighths are unshaded? 1/8, 2/8, 3/8, 4/8, 5/8, 6/8 are unshaded. 10/8 are shaded. 6/8 are unshaded. Do your best. Take your time. You guys can do this.